prokaryotic ribosome question, we give you a diagram and we ask you to locate as accurately as possible the listed items below. Some items are not shown, meaning that some letters are just not present on this diagram. The first letter, A, we ask you to identify the 5' end of the DNA template. Because we know that we see here a ribosome and we know that the ribosome reads in a messenger RNA, we do not see any double-stranded DNA sequence in this figure, so therefore there is no 5' end of the DNA template on this figure. In B, we ask you to identify the 3' end of the messenger RNA. Because we see a ribosome with an arrow that goes from the left to the right, we know that the ribosome reads in the 5' end first and then it goes towards the 3'. We know that our 5' is located right here, whereas our 3' end is located towards the right. In C, we ask you to locate the promoter region. We know that the promoter region is located on the double-stranded DNA, and the role of the promoter region is for the binding of the RNA polymerase to form the messenger RNA. Therefore, we don't see any DNA in this diagram, so we can't identify the promoter region. In D, we ask you to identify the 5' UTR region. We know that the UTR region is an untranslated region. Because it's the 5' one, it will start at the 5' end all the way to the start codon, and your 3' untranslated region will go from your stop codon to the end of your promoter. Of your messenger RNA. In E, we ask you to identify the 70S ribosomal complex. So we know that in prokaryotes we have these subunits. So this subunit is the 15S subunit, 50S, and the one below is the 30S subunit. These two subunits together in prokaryotes form the 70S ribosomal unit. In F, we ask you to identify the sites A, P, and E. So we can start by identifying the P site. The P site is the peptide formation site. And in this diagram, what we see is that the peptide formation seems to be right there, which would be located at the site in the middle. The arrival site, or the A site, is the site where we will have a tRNA charged with an amino acid that will arrive. And this will be located right here. And finally, our exit site is the site where the uncharged tRNA will leave the ribosomal complex, which is right here. In G, we ask you to identify the N-terminus of the polypeptide. You can think of the N-terminus of the polypeptide being similar to the 5' end of a DNA or RNA sequence. So polypeptide chains are similar to DNA or RNA sequences in the sense that they have a direction. They go from 5' to 3' for DNA or RNA, but in polypeptide chains, we go from amino end to carboxy end. And the amino end will actually be at the beginning. It will be an NH2. And towards the end, we are going towards a carboxy end, which is identified as the COOH1. So you can think of this as being similar to the 5' is the base where we have our phosphates attached. Our phosphates attached is not where we add more, but it's instead at the 3' carbon where we have an OH that's attached. And this is where we always have new bases or new nucleotides that come to form the DNA sequence or RNA sequence. In polypeptide chains, we have the amino end and the carboxy end. The carboxy end has the OH, and this is where we have always a new amino end from another amino acid that will come to form that chain. So this is where our amino end, or the N-terminus of the polypeptide chain, is located. In H, we ask you to identify the anticodon for FMET. FMET is 4-methionine, and it's always going to be the first amino acid that is being added to the polypeptide chain in prokaryotes. So as we see, this is our 4-methionine. Because we know that this tRNA carries this amino acid, we know that this is probably going to be our tRNA for the F-methionine. Therefore, the sequence that is going to be located right there is our anticodon for our 4-methionine. In I, we ask you to identify the 3' end of an uncharged tRNA. So the first thing we want to do in this question is to locate our uncharged tRNA. Our uncharged tRNA is going to be right there, and this is the one that carried our methionine. The 3' end of the uncharged tRNA. So we know that tRNAs look something with loops. So please don't ever hold me accountable for this drawing, but we have a 3' end that's going to be right here. This is where we have our anticodon sequence, and this is where we have our 5' end. So because this is what our tRNA looks like, from this figure, this is where we will identify our 3' end. In J, we ask you to identify the peptide bond. So I've talked about peptides a little bit earlier. We know that if this is one amino acid and we have another one here, if they're represented by these little purple balls, we know that our peptide bond will be located right here. In K, we ask you to identify the amino acid proline. So to identify the amino acid proline, what we need to do is look at these tables. These tables have the sequences on the messenger RNA that codes for specific amino acids. So if we know that proline can either be CCU, CCC, CCA, or CCG, what we do is if we go back here, we find this mRNA sequence, which corresponds to a proline, which tells us that proline is located right here, which was carried by tRNA that had an anticodon that had a sequence that matched with the messenger RNA codon here. So this is probably the carrier of your proline. In L, we ask you to identify the amino acid glycine. So if we go back to our table, we look for glycine, it's right there. Glycine is either GGU, GGC, GGA, GGG. If we go back to our figure, we do not have these sequences located on our messenger RNA. If we don't have those, we know that we won't have an amino acid glycine in our chain right here because we don't have the messenger RNA sequence for glycine. In M, we ask you to identify the threonine tRNA that carries a threonine. So what we need to do is find the messenger RNA codon sequence for threonine, which is one of these four, which all starts with an A and a C and can have any nucleotide at the last position. When we go back to our figure, we see here ACG, which tells us that probably this right here is the messenger RNA sequence for the threonine. If this is it, and we know that our tRNA here will come at this position, at this arrival site, it is probably the tRNA that carries our threonine right here. In O, we ask you to identify the RNA polymerase. We note that the RNA polymerase synthesizes the messenger RNA from the double-stranded DNA, and as we did for the other questions that asked for DNA, because we don't have any DNA in here, we do not see any RNA polymerase. We only see our messenger RNA and our ribosome. I've skipped N, sorry. And we ask you to identify the threonine tRNA synthetase. So the synthetase is actually the enzyme that will attach our amino acid to the tRNA. Because here we see that our amino acid is already attached to the tRNA, we don't see the enzyme that actually synthesized this reaction, so we do not see the letter N on this diagram. In P, we ask you to identify the wobble position. The wobble position is the position at the 3' end of a codon. So if we think of a codon as being 3-letter, 5' to 3', the 3' end of that specific codon will be the wobble position. And the wobble position is a position that can carry different nucleotides, but that will still attach to the same tRNA that carries a specific amino acid. So the wobble position, if we look at our arrival site, it will be this one, which is the last letter of a codon that's nearest to the 3' end of the messenger RNA. In Q, we ask you to identify the codon for threonine. So to do this, because we know previously that this is the threonine tRNA, we know that this is the codon for our threonine because we looked at this earlier in our table. And finally, we ask you for the stop codon. So we know that if we go back to the table that we had previously, our stop codons are either UAA, UAG, or UGA. If we go back here, what we see is that our stop codon is located right here towards the end of our messenger RNA, included in the untranslated region.